Alrighty. Well, hello everyone and welcome. My name is Sakira Abbott, and I am the Digital Archives and Communications Fellow here at the National Women's History Museum. If this is your first Zoom webinar session, which is different than Zoom meetings, you'll notice there is no chat feature, only Q&A for you to submit questions that will be answered later in this panel. And as you may have already noticed, no camera for each registrant, so no worries there. Thank you all so much for joining us on this very special day, the birthday of Dr. Vera Rubin. A pioneering astronomer, Dr. Rubin's research helped confirm the existence of dark matter and open new frontiers in our understanding of the universe. But beyond her scientific achievements, Dr. Rubin was a dedicated mentor and a passionate advocate for young women in science. Timed with the release of her commemorative quarter through the U.S. Mint's American Women's Quarter program, today's celebration honors Rubin's legacy in both science and mentorship. We come together not only to reflect on her groundbreaking discoveries, but to embody her spirit of support, encouragement, and advocacy for the next generation of women in STEM. Let this space be one of reflection, learning, and connection as we celebrate what it means to make space for science, for equity, and for every girl who dreams of exploring the stars. As we honor Vera Rubin's legacy and look ahead to the future of women in STEM, we are so excited to be guided in today's conversation by two brilliant leaders from a world of women in STEM, or WOW STEM. Their work embodies the same spirit of mentorship and empowerment that Vera championed throughout her career. Please join me in welcoming our moderators, Dr. Madeline Lean-Bruggen and Dr. Taylor Contreras of WOW STEM. Dr. Madeline Lean-Bruggen is a researcher turned science communicator. She graduated from Harvard University in 2024 with her PhD in theoretical soft matter physics, and she is now a freelance writer, curriculum developer, and video producer. You can usually find her over at SciShow on YouTube or at the nearest coffee shop learning about any and all science. Dr. Taylor Contreras is a high energy particle physicist studying the most fundamental and tiniest building blocks of our universe, like electrons, photons, and her favorite, neutrinos. The neutrino is also known as the ghost particle because it barely interacts and can even go straight through the Earth. Taylor works as a research assistant at Fermi National Accelerator Laboratory, which hosts an intense beam. With that, I'll turn it over to Madeline and Taylor to lead us in what I know will be a very powerful and inspiring conversation.
Great. So I will go first. As Sakira introduced, I'm Taylor Contreras. I'm actually Vice President of WOW STEM with Madeline as our president. And we have educational blogs and videos all about women and gender minorities in STEM. We actually had a very early blog on Vera Rubin, so I'm very excited to be a moderator on this panel celebrating her life. I think that dark matter was one of the most interesting things that got me into physics in the first place. And I'd say one thing that inspired me about Vera Rubin's story is really her confidence in her research. It was the first evidence of dark matter was very controversial. And I really am inspired by her confidence in that work and continuing on. I'll pass it off to Madeline.
Yeah, thank you, Sakira, for such great introductions to this event and for me and Taylor. As Taylor said, my name is Madeline Lean-Bruggen. I'm the president of WOW STEM. And yeah, we worked on this very early project about Vera Rubin. She was one of our first like 5 people that we profiled when we started WOW STEM. I studied dark matter as an undergraduate, and her story stuck out so much to me because at that time, I still hadn't really known about many women in physics or women in astronomy. And her story was one of the first times when I really thought to myself, okay, this is something that I could do too. This is a career that I could have. So it's really such an honor. It's so exciting to be here celebrating her birthday, celebrating her quarter. Taylor and I have backgrounds from the new Rubin telescope down in Chile. So really excited to be here today with so many amazing, brilliant panelists as well. And we'd like to introduce you to them. We'll give some short bios for each of our panelists.
So starting off, we have Barbara Esker, served as a Deputy Associate Administrator for programs in NASA's Aeronautics Research Mission Directorate. She oversaw cutting-edge research focused on transforming aviation and advancing sustainable flight technologies. Welcome, Barbara.
We have Dr. Kristen Thompson as well. She's an associate professor of physics at Davidson College and now studies how magnetic fields affect the birth of stars. So using radio telescopes like Arecibo and the Very Large Array, she observes the Zeeman effect to investigate why star formation is far less efficient than expected. Her work sheds light on the hidden forces shaping galaxies and deepens our understanding of how stars and eventually planets and life come to be.
Dr. Sara Seager is a professor at MIT and a trailblazer in the study of exoplanets, worlds beyond our solar system. Her research spans the detection of exoplanet atmospheres and the search for signs of life and the development of space missions, including TESS, Asteria, and Venus Life Detection projects. A MacArthur Genius Grant recipient and member of the National Academy of Sciences, she continues to expand the frontiers of planetary science and space exploration.
Dr. Rachel Beaton is a postdoc research fellow at Princeton University with a joint affiliation at the Carnegie Observatories in Pasadena. She studies the halos of galaxies, which are their outermost regions, to uncover how galaxies form, grow, and retain traces of their past. Her work combines deep photometric surveys and large-scale collaborations to explore galaxy structure, dark matter, and the cosmic distance scale.
Yana Wilson is now a graduate student at Michigan and previously a post-baccalaureate researcher at Argonne National Laboratory, specializing in computational cosmology. Her research focuses on the evolution of early universe protoclusters and the galaxy halo connection to better understand large-scale cosmic structures. In addition to her research, Kiana is a passionate science communicator dedicated to increasing representation and diversity in STEM fields.
Welcome to all of our panelists. Thank you so much for being here. To kick us off, we'd love to hear from you guys how you first learned about Vera Rubin's story and what you find most inspiring about her legacy. Is there anyone who would like to start, or I can call on someone if that'll help? Maybe Kristen, could you kick us off? Oh, sorry, Kiana. You can go next.
Sure. Hello, everybody. Vera Rubin's story is certainly one that was really inspiring to read about and learn about. It's one that I share with my students to try to inspire them as well. Taylor, I think it was you that mentioned, just persisting with your own work when others believe that maybe you hadn't done something right, believing in yourself, believing in your own work, standing up for yourself. I think those are all really important lessons. One of the other things, in addition to that, that I find really inspiring about Vera, was I'm the mother of two young children, and part of her story is as she had children, trying to balance all of the things that was going on in her life, right? She had to stay home for a while and wasn't able to do all the things that maybe she wanted to. Part of the story, she talks about watching her husband go to work and do the things that he loved while she had to stay home and take care of the children. And I think it's really admirable the way that she, found a way to make it work in a time when many women weren't able to do that. Right. So there are many inspiring things, but that's something else that sticks out to me.
For me, dark matter, again, someone else mentioned, was one of the concepts in astrophysics that most piqued my curiosity. It's something that I work with on a day-to-day basis as a cosmologist. And so that was the way that I first learned about Vera Rubin. But I think what I find most inspiring about her story, and something that I talk about a lot as a science communicator, is the ways in which historically women scientists' work has either been erased or stolen, or sort of we don't hear a lot about the work and contributions of many women scientists throughout history. And so I think it's just so incredible that this woman astronomer has cemented her legacy in astrophysics and cosmology. Dark matter is now, excuse me, a major component of our standard model of cosmology, right? You cannot talk about cosmology, astrophysics, mostly anything in these fields without incorporating dark matter, and knowing that her name and her legacy is forever tied to that is just so incredible. So we can never ever forget her name and her legacy and her story.
Rachel, do you want to jump in next?
Yeah. So when I was an undergraduate, actually at the University of Virginia, I actually was part of a project where we were interpreting new infrared images of M31, Andromeda, the Andromeda galaxy. And that's a galaxy that Vera studied a great deal. Actually, her really famous work was actually doing these profiles of the Andromeda galaxy out to very large distances. And so I intersected with her mostly from her scientific work and not her story per se, because the images that we had from the 2 micron all sky survey were actually able to interpret or reinterpret some of her work in the early 80s that were published. And that is that the gas in this galaxy was moving in a way that didn't make sense if Andromeda was a true spiral. But if you instead thought the galaxy was a barred galaxy, the motions of the gas in the inner parts of the galaxy could be understood. And that's what our new data was actually showing. So then I found out about Vera Rubin. So I grew up in a very, very small town. And um, so I didn't know a lot of scientific backstory. But I actually got to meet her when I made a poster and went to the American Astronomical Society meeting. They did a special event for undergraduates to showcase their research. And she was actually the speaker for that event, as well as went around and got looked at everyone's posters. And it was really inspiring that someone who's that famous and that important in the grander narrative of science, took the time out to talk to undergraduates showing research for the very first time.
Go ahead, Barb.
Can you hear me now? So this is absolutely fascinating, and I'm sitting here as the only person on this panel, or maybe in the entire seminar, that's not a space scientist. I'm an aeronautics and aviation research engineer, and the stories that you're telling about Vera Rubin are just eye-watering and just so inspirational. But I was going to open the aperture just a little bit further and say there's amazing, inspiration in so many other areas. I mean, certainly. I look to the women that have been part of our astronaut corps. I mean, some of them have been absolutely fascinating. I've had the chance to talk and get to know several of them. But I also want to point out that for me, some of my inspiration comes from the hidden figures. Katherine Johnson, Mary Jackson, and similar to the previous speaker, I had a chance to actually meet Christine Darden. So Dr. Christine Darden was a research engineer at NASA Langley Research Center, and she did some of the very fundamental work on sonic booms and how they are created and how they might be managed and reduced. And I was a young engineer, maybe 5 years out into my career, and had a chance to meet Christine, and she was just so gracious, and her ability to bring me in and make me feel comfortable and at home was just absolutely heartwarming. So there's some really amazing women out there, and to the point about sometimes the history gets lost or the stories get lost. I agree 100%, and it's going to take us taking the initiative to find those stories and tell those stories and retell those stories to keep them alive.
Thanks, Barb. Sara, do you want to wrap us up on this question?
Sure. I did find inspiration from Vera, and I was fortunate to work in the same place as her for a few years, where she had just retired and I was a new hire. What I loved about Vera was she found a workaround to things. She didn't certainly ever complain about being a victim, but she just took matters into her own hands. So she told me that she worked at Carnegie because one day she realized, with her 4 kids being really young and having to live in Washington, D.C. because of her husband, she asked if she could have a job there because there was no teaching. So, she found a workaround to make her situation work. The other thing I think we should take notice of is how she was able to succeed so wildly. You have to ask yourself, what can you bring to the table? And what she did there is she worked with an instrumentalist, someone who was building a new instrument that could do better in astronomy than anything existing. And she was able to use this new instrument to study the outer regions of the galaxy to discover dark matter. So I think it's inspiring for all of us that I do think she purposely chose to work in an uncrowded field, right? Which is what you have to do if you want to make progress. And of course, there also has to be a bit of luck involved about what nature had provided. But the fact that she purposely took advantage of a new instrument that was built in-house that she had a monopoly over, I think that's the kind of thing I take inspiration from, is how to make your own way through the world.
Thanks. These were all very great answers. I can see how much Vera and her story has really inspired everyone. So our next question is open to everyone, but for whoever feels inspired to answer this one, we'll take a few answers. So Vera Rubin often credited her early curiosity and inspiration from her father and the first female astronomer, Maria Mitchell, as key to her scientific journey. Did you have someone or something in your life that sparked your interest in the field and helped guide you at an early age? Anyone inspired to answer, or I can, yeah, go ahead, Kiana.
Yeah, this is always a very interesting question for me, as someone at the intersections of multiple identities. So growing up, I actually didn't have much representation of Black women in these fields. I think the first Black woman physicist or cosmologist that I had come across was Professor Chanda Prescott Weinstein. And that wasn't until high school. And I had discovered my love of the universe at the tender age of 9. So between then, up until then, I essentially, very similar to what Dr. Seager said, I had to sort of forge my own path and make my own way, with very little representation, very little guidance, very little access to resources and opportunities, coming from a low-income background. And so I just took the initiative. I did my research. I tried to find programs where I could learn more about these things. I tried to reach out to people I found online. I just consumed so many books, just watched so many shows on the Science Channel, so many documentaries about space. And in that way, I sort of, in the beginning stages, had to do a lot of it on my own. And that is why I today am so passionate about being that representation that I wish I had in those early years, because it's just so powerful, and it gives you permission to sort of believe in yourself and to see yourself in these fields when you have someone to look up to who's there and succeeding, and even better, someone who looks like you, who shares some of your identities. So maybe not the exact answer you were looking for, but that is a bit of my story.
It's always great to hear. Thank you so much for sharing. Barb.
So as Kiana said, this is always an interesting question. From my One of the things that was most interesting or most inspirational to me was that my mom in 1958 entered college in chemistry, where she was the only woman in the entire chemistry program and curriculum, and and she stuck to it. None of the men would work with her except for one. One finally, relented and worked with her as a lab partner, but they did not accept her. They did not include her, but she persevered and graduated with a degree in chemistry. And to me, that's very inspirational. We do have to forge our own paths, and we have to stay true to ourselves, to continue to make the progress and do what we want and what we love. From an aeronautics and aviation point of view, I remember being probably about 4 years old, and my dad took us to the Air Force Museum to look at the airplanes. So I think from a very early age, his love of aircraft was just generally infectious. And I was very fortunate to have both of them, getting me on the track and on the path that I am.
Thanks, Barb. Rachel.
Yeah, so I grew up, actually, it's where I am now, here in rural Southwest Virginia, and I grew up on a farm, surrounded by nature, surrounded by plants, and was able to ask questions about, sort of biology and chemistry, and sort of figure those things out using my, whatever tools I had available. But when I was in elementary school, there were some pretty famous comets that came around. There was Comet Hale-Bopp Hale-Bopp, and then there was also Shoemaker-Levy 9 that smashed into Jupiter eventually, and Comet Howard-Take, I believe. And so my dad and I went outside on the farm and tried to take pictures of the comet. Now, you can't just take a picture of a comet. You have to you have to take a very long exposure. So this is a film camera. You have to take a very long exposure, and then the sky is actually moving. And back then, this is film, so we didn't know how terrible all of our photos were until it got developed the next month or so. But then, I just was like, okay, well, let's try to take a picture of something else. And so I started going, the internet in rural Virginia was very new at the time. So I was doing research and trying to learn as much as I could. And with astronomy and I did a lot of planetary science, I just felt like could never find the end of knowledge. I kept having more and more questions. And I really fell in love with astronomy that way. But also being from rural Virginia, I had to work extremely, extremely hard to be competitive, to go to college and all that kind of stuff. But it was that just quest to know more that really inspired me, and feeling like I could never know everything that really pushed me through and made me fall in love with science.
Thanks so much for that answer, Rachel. Kristen.
Perhaps this is a great follow-up to Rachel, because I think she could probably second many of the things that I'm going to say. I also grew up in a rural community in Ohio. It was a very small town. It was 30 minutes to the nearest gas station, grocery store, you name it, type of place. I see her nodding her head. And, along with that comes darkness, right? No street lights, no cities, no businesses, occasionally someone wandering around with a flashlight, but that was about it. So our sky was very dark, right? And that was really the first inspiration to me, was just the ability to go outside and look up and be able to see the stars, to see the moon, to see the Milky Way, to be able to do cometary photography, like Rachel mentioned. And unfortunately, I mean, I consider myself very blessed to have grown up in that environment, because I could walk out and I could do that anytime that I wanted to. But for many people, that's not the case. Many of you who are even here, most of you probably, are from very populated areas where there's a lot of light pollution, and you probably can't just go outside and look up and be able to see the same thing. So, I applaud you all for being here, because I think sometimes it does take an experience like that For Barb, she mentioned it was her dad bringing her to see the airplanes, or, for me, it was just being able to look up. It sometimes takes that experience to be able to do that. So, keep looking for opportunities. If you get a chance to go somewhere dark, do it. And I always tell my students through all my community engagement programming I always say, just keep looking up no matter what you do. Because sometimes you find inspiration in sometimes the least inspiring of places, out in the middle of nowhere, for instance. So that's my story. And also, I encourage you all to do that.
Thanks, Kristen. Yeah, I myself didn't get to see a very dark sky until early undergrad. I think it was very inspiring when I finally saw that. Very cool. Sara.
Well, I'll echo what everyone said. I was inspired by the stars. I grew up in the inner city. You could still see Orion. And the moon, of course, is so spectacular, right? When I got to go in the car with my dad to stay with him on weekends, I just remember the moon wouldn't stop following me. I bet you some of you had that. You walk down the street and like the full moon, right? Like never goes away. And it's so good when the parents can't answer that. Like be like, why? And so that echoes what Rachel said. You just want to know more. I guess just to be different, I'll give a shout out to the anti-role models. Having also grown up in a nasty, nasty environment with a monstrous stepfather, I kind of realized that I don't have to listen to authority, and that was incredibly helpful. So I love Kiana's story, and it's like sometimes you just have a really like you just have to find your own way through. And yeah, it was so helpful when I became a scientist because I didn't feel like I had to listen to what people said or whatever the established truths were. So I share everyone's inspiration from the night sky, and I just love how astronomy can be for everybody, even in the inner city.
Oh, I loved hearing all of those answers. It makes me excited all over again to be a scientist and to get to think about these things and talk about these things. Um, Barb, this next question is for you specifically. And as a tangent, my dad is also an aerospace engineer, so I also grew up going to a lot of plane museums and getting very excited about it. So I want to ask about your leadership within NASA Aeronautics, helped bring, some really impressive tech like urban air mobility and supersonic travel into reality. And these are fields not traditionally led by women. So, we're talking a lot about Vera Rubin's legacy of pushing those boundaries and scientifically, and also in terms of inclusion and carving a path for herself and others to come. So I'm wondering how you built ideas of inclusion into your leadership and how that shaped engineering cultures or has the power to shape the culture that we work in.
So thank you. That's a really good question. I think about inclusion in a very three-dimensional way. It is not just two dimensions. And I think from a professional point of view, I learned my biggest and earliest lessons on inclusion actually was from my technical mentors. And my technical mentor was a gentleman named Jack when I first hired at NASA. And he was an original NACA engineer, NACA, which was the predecessor to NASA, the National Advisory Council on Aeronautics. And so he had a deep background in fundamental aeronautics research. But what was so inspirational to me was when Jack led a research team, he included everybody. And that was by race and gender, but it was also by degreed and non-degreed. And he just modeled the importance of everybody on the team. And it didn't matter if you didn't have the degree, excuse me, our mechanic and our technicians and our electronics techs, they were just as much a part of the team and they were just as much listened to and contributing. So I think from a very early professional point of view, that's what struck me. It's all about the people and it's all about all of the people because everybody is an expert in something. And your job as a leader is to bring that together for the benefit of what you're working towards. And over the years, it's just been I've had the good fortune to work with some really, really amazing scientists and engineers. I mean, we've cracked the code on sonic booms. We know how to eliminate sonic booms. The next step is demonstrating that in flight. And so I bring that up because we're building and we'll be flying the X-59 research aircraft to demonstrate that elimination of the sonic boom is possible. But that project is led by a woman by the name of Kathy Baum. And Kathy herself is inspirational, and her ability to bring that aircraft, lead the team and bring that aircraft into reality is just again heartwarming for me, inspirational to me. So it's a matter of thinking about people and thinking about how everyone contributes, in a very three-dimensional sense of the word.
Thanks, Barb. Keeping on this discussion of pushing forward despite exclusion, and how this is related to Vera Rubin's work in working in a very male-dominated institution, I want to aim this next question at Kiana in particular. So I know you spoke a bit about how your identity has affected your the role models that you see growing up and your and such. So as a first-generation college student and advocate for unapologetic representation, I really feel like you can embody Vera Rubin's spirit in this trailblazing beyond social limits. So in particular, have you faced obstacles in your own journey? And if so, what helped you persist? And what does it mean to you to actively make STEM spaces accessible for young girls whose identities are often overlooked?
Oh, yeah. So definitely faced a lot of things, which is incredible because I'm still so very young in my career. So yeah, everything from, coming from a low-income background, first generation college graduate, having sort of no resources. I couldn't lean on family to sort of help guide me. And when I got to college, just a lot of microaggressions, from professors and peers. I think it was a combination of feeling like I wasn't as equally prepared coming into these spaces as a lot of my peers, and also the severe effects of like isolation on account of being a one of one in all of these scientific spaces, and especially in such, elite scientific and academic spaces where there's often a lot of, elitism and classism and all of these isms and phobias. It was a lot all at once to navigate as someone with, again, an intersection of identities, and having forged my own path up until that point and continuing to forge my own path. I hit a breaking point, definitely. And the one thing that sort of got me through it, all right, it was two things. The first thing was I'm very fortunate to have known from such a young age that space was my passion. And from that young age, because of the circumstances of how I grew up, and they're very statistically is very unlikely for someone like me to be here in these spaces. I really latched on to, excuse me, to this idea of being an astrophysicist. So once I discovered my love of space, it was like an immediate love. Like, I am an astrophysicist. I don't have any degrees. I don't have any sort of expertise yet, but I'm going to work my butt off and I'm going to get there, and I'm going to get to college, and I'm going to graduate from college, and I'm going to pursue this path because this is what I am, and this is how I can see myself beyond the sort of narratives the world has projected onto me, that I didn't get a say in. So that has always been my moral compass in those hard times that got me through those hard times. And then the second thing was not seeing any representation, intersectional representation, something very important to me. I had to create it for my own. So I went out and I created community. I found the other two Black women physicists in my department as an undergraduate. They were PhD students. And I was on my last limb. I reached out. but before I even found them, I should say, because someone said something very similar earlier, at that low point in college, I was sort of Googling Black women in physics. And I just sort of went down this rabbit hole of desperately needing to see someone who looked like me in these fields. And so that's how I found them. And I reached out, out of desperation, honestly. And they just immediately, took me under their wing. They're some of my closest and dearest friends today. And so I'll definitely say like it's just so important, representation and seeing people who look like you, and also building community and these support networks around yourself, because no matter how strong you are, how secure you are, how much you've done on your own, it's unsustainable to continue trying to do things on your own for so long. So yeah, what was the second part of the question? Sorry.
Yeah, no problem. The second part was about like how what does it mean to actively make STEM spaces accessible to young girls? And I think you already mentioned that, you had to go make that space for yourself. So can you speak on how you did
Absolutely.
that?
I think for now, or now, what truly a fundamental sort of tenet of my value system, in terms of being a science communicator who advocates for intersectional representation and unapologetic representation. My motto, right, is busting barriers in science through unapologetic representation is showing people, whether it's young women, young Black and Brown students, intersections, Black and Brown women, queer individuals, any combination of marginalized identities, that you can be in these spaces and you can show up as yourself completely authentically, unapologetically. You don't have to make yourself overly palatable. You don't have to make yourself small. You don't have to silence yourself. And I think, advocating for that and seeing people who embody that in these spaces just gives so much permission that a lot of time folks don't know that they need in order to enter these spaces, and if they're in these spaces already, just to continue along. So I think there's just so much power in unapologetic representation and intersectional representation as well. And so I will just keep screaming it from the rooftops. And it's just like the first step I feel towards making these spaces more inclusive and equitable and accessible, for all, because as we said earlier, astronomy and space, is for everyone. Like no one can gatekeep the stars from you.
I love everything that you had to say, and can really relate strongly to this idea of like just really needing people that you can look up to. This is one of the reasons why Taylor and I felt so strongly about founding WowSTEM. We were like talking with our team of other co-founders, and at one point we said, well, why don't we just make the thing that we wish had existed when we were middle schoolers interested in this stuff, who really desperately needed those people to look up to. So I I love your catchphrase and this idea of unapologetic representation. I think that's the way that we keep bringing new people in and hearing new voices. Love to hear that. So I have a next question that is open to anyone who wants to answer. So Vera's work on galaxy rotation and dark matter really unexpectedly reshaped our understanding of the universe. I think Taylor alluded earlier that this is, you know, it took a lot of guts to say that this is a big change. This is really weird, but it's right, and we had to reshape a lot of the way that we think about the universe because of this. And dark matter is still one of the biggest unanswered questions in physics. Tons of people working on it. Um, so more broadly, looking ahead, everyone is in a slightly different field, a different section of research. So I'm wondering what unanswered question in your field excites you the most right now? What do you think in the next couple years we might finally start to get some answers on? And this is open to anyone.
I'll just jump
yeah.
in. In astronomy, we're always pushing the frontiers. And in my own personal field of exoplanet astronomy, we're kind of faced with tiny signals and noisy data. But one thing I'm really excited about is laboratory astrochemistry. And we're trying to, in the spirit of Vera doing something way out there at the time, we're trying to understand if there's possibility of life in non-water solvents. And we're doing that like with repeatable high signal to noise experiments in the laboratory using concentrated sulfuric acid and other non-water solvents.
I think that's such a cool application, bringing the stars to us to work things out. Rachel.
Yeah, something I've been working on a little bit recently. I've been involved in trying to help shepherd NASA's next great flagship, which is the Habitable Worlds Observatory. And the idea is that in a while, once we build this observatory, it will have the capabilities to actually directly image a Earth-like planet around a nearby star. And what I mean by directly image is you have to block out the light of the primary star and then see the planet, which can be 10 billion times fainter. And once you isolate that star, the planet, you can then send that through an instrument and actually learn about the planet independent of the star to some degree. And that's extremely exciting. However, putting something in space that can suppress starlight by a factor of 10 billion is really hard. But there is an instrument that launches on Roman, the Roman Space Telescope, which launches in a year. There's a coronagraph that is going to try to do one part in 1 billion, which is what you have to do before you can do one part in 10 billion. And that instrument, is so stable. It requires an observatory that can point very stably. It requires an instrument that can, or sorry, a telescope that can stay at the same temperature because temperature fluctuations will knock things out of alignment. It requires just this tremendous amount of technology and science to go perfectly. And the thing that's really exciting is that it kind of works so far. I was in the lab and I got to see the instrument and I literally tripped over something in the lab because I'm a very klutzy human being. And they could see it in their stability data, just a person tripping over something in the lab. And that's like the degree, just it blows your mind what, so a different type of laboratory astrophysics, this is in micro devices, are able to do. And I think we're really going to be able to make this stride in the next couple of years. We launch in a year. And that will open up, possibly the ability to even look at some of these exoplanets and see the signatures that what Sara mentioned, laboratory astrophysics, are going to try to tell us what those signatures might be.
I'm a theorist, so anytime anyone ever talks about instruments in a lab, including Taylor, she'll tell me about the instruments that they're building, and it just blows my mind because I spend all day staring at the wall and doing math, but very cool to hear about. Yeah, Kiana.
Yeah, very briefly, the recent Dark Energy Survey or DESI results has just been truly fascinating. When we first developed like our theories around dark energy, it made sense at the time to set it as a constant with the information that we had. But similar to or along the lines of what Rachel was saying, like we're in the era now of like precision cosmology, and we're creating these like very advanced telescopes and observatories that can just capture detail and data like at scales that are just unbelievable and with just incredible precision. And so just seeing all of this new data come in and seeing how something that we thought was relatively, set in our major model of the universe ultimately not be, and what that could mean for other things we may discover about the universe. It's just super, super fascinating. So, as a theoretical cosmologist, you're very similar to you. I'm just head is a buzz with all of this, fascinating talk of dark energy not being a constant potentially.
Go ahead, Taylor.
Yeah, I love to hear about new interesting detectors or observatories and telescopes. All that technology I think is my favorite thing in physics. So very cool. So if no one else had wanted to speak up, on this question, we can go to our next one, which is aimed at Sara. So, Sara, you study exoplanets and search for signs of life in distant corners of the universe. It takes a lot of creativity and confidence to imagine new versions of reality. Vera had to do that when she discovered a bunch of invisible mass, as we talked about. So, how do creativity and confidence show up in your work? And why do you think it's important to ask big questions, even though others might not see the value or importance in them?
Yes. Okay. So there's a lot there. I'll just briefly address search for signs of life. We've definitely hit a roadblock, I'd say, because we've just realized how hard it is, even with Habitable Worlds, whatever gets launched. You're looking for a tiny signal and a lot of noise, and that signal is very ambiguous. A lot of other molecules can be assigned to it. So it wasn't what you asked about, but sometimes you have to take a sigh and be like, oh, okay, what can I do about this situation? So people have worked really hard to capture all possibilities that the data can tell us, even if we can't end up with like a unique, robust answer. I mean, perhaps there's some creativity in that as well. But in terms of what role does creativity play? It plays a giant role, as does being open to, I mean, some people might call it luck, but being open and prepared to take new opportunities. For example, I was involved with the phosphine on Venus. I was going to say discovery, but let's say the phosphine on Venus controversy, where I was part of a team that announced a reported detection of tiny amounts of phosphine on Venus that we cannot explain with all known chemistry after 100 pages of concrete analysis. Perhaps it left room for the possibility of life making phosphine on Venus. And it was very controversial because the signal's tiny and the data's noisy. There may be one other gas instead of phosphine it could be. And even if we believe the signal and that it is phosphine, there's many other interpretations that we can't assess properly because unless we go to Venus. So there's some definitely open thinking, and I used that opportunity to be creative again. And that led to my whole new laboratory chemistry effort in thinking about life in concentrated sulfuric acid, which I know people aren't chemists here, but it's super, super crazy. It has like the giggle factor. Only one person who knows something is giggling here. But if you were to put our life in sulfuric acid, which you probably shouldn't try it at home, although you could technically like put an ant in sulfuric acid, which one of my sons who was working on the project did. That's why I know it's like, but where's your creativity to think something could survive? We tried biomolecules, amino acids, nucleic acid bases, and a lot of things are. So there's so much creativity and nerve involved. And sometimes, it's like that moment where you're just cooking dinner or like walking your dog or in the shower, just some moment when your mind isn't really on your problem. Do you ever have this? And like there's this sort of feeling, and it could be about a person or a thing or your science if you're geared up for it. And that's also intuition. So the creativity, intuition, strategy all come together. And I definitely know that Vera had all of those things.
Go ahead, Barb.
Listening to the conversation, it is truly inspirational, but I want to take it back to some of the previous conversation we had in that I would submit that the creativity is manifest or strengthened through the diversity of working with others. I mean, how many times do you get into a brainstorming session with people that think a little bit different than you? And the ideas build and the creativity builds and bubbles. And so, there really is a very tight connection between creativity and diversity and inclusion. And that's something that none of us can ever lose sight of. And that's the very broad us, when not just us on the line here. It's really, really important because the whole can be so much more than just the sum of the parts.
Absolutely agree. I think something that WowSTEM taught me a lot of was, working with so many other amazing people who were so passionate about this idea of, telling more people about the stories of amazing scientists who have come before. Yeah, getting to work with such a diverse and spread out team has been one of my favorite things about WowSTEM. We had collaborators from all over the world at one point, and seeing the different ways that everyone thought about everything made it such a stronger project, and that's absolutely true for science as well. Okay, my next question is for Rachel. So you've been mapping Andromeda's stellar populations and also leading outreach and inclusivity committees like COINS. So your work really mirrors Vera Rubin's dual innovation in science and advocacy. So I'm wondering how you view the role of inclusive research programs, and how does mentoring youth continue Rubin's legacy? How does that, feed into this picture of a more inclusive science that we have?
Yeah. It gets back to what Barb was saying is that a lot of our, all of us have a path that we took through life, and have certain attributes, and that gives us a way of looking at things. And looking at things differently is really important. So I do a lot of big teamwork in preparing for the Roman Space Telescope, and having people who have different scientific backgrounds, different human backgrounds, means that they look at something as silly as I don't want to say silly, it's a very interesting field, a user interface. Okay. So just going to a website to say I want my data, um, everyone looks at that website differently. And I'm just using this very simplistic example, but it's, and being able to listen to everyone's perspectives and the path that they take through information and the way they process information helps you do a much better job. And the more I work with more diverse people, which is, I see diversity on so many different axes. There's your human diversity, but there's also the path you took through life, places that you're from. There's your age and your familiarity with material. Because right now I have summer interns, and they are unfamiliar with material. And the questions they ask are not questions that I would ever ask per se, because I have a way of thinking about it and I think about it the same way. So when I think about mentoring and I think about bringing people into the field, I just think about all the ways that they can look at the same thing that I'm looking at and I think about in a certain way and give me new vision. And then I can help them shepherd that vision through. Vera looked at the Andromeda galaxy and said, I wonder what happens if I just keep going, right? In this observation I'm taking. And those kinds of insights, they're fearless when we look at them in hindsight, but I think you still have fear in the moment, like it could go wrong, it could not work. Um, but the bravery is ignoring the fear and saying, well, I'm going to do it anyway. What's the worst case? I lose a couple hours of data or something, right? Like, what's the worst case? And I think Sara brought up that she had this instrument to herself. So you could do high risk science where the reward could be, an observation that helps us reimagine the components of the universe, or it could just be some data you never do anything with. And so as I sit, in my sphere, I think a lot about how competitive science is right now. And this is not to discourage anyone from being a scientist. You should do that. But we are in a situation where we have a lot of compressed resources and funding. And sometimes I have to submit 5 or 6 grants to get one, that cycle. And I just wonder how much we're losing some of the ability to do high risk because we have such limited resources that you can't take that new and fun idea and pass it forward unless you're at an institution that can give you some innovation and design funding, some funding to do something risky, so to speak. And as someone who leads a lot of inclusion efforts, when new people join a collaboration or join a project, you really want to listen to the views that they have, because sometimes your high risk, high reward kind of ideas come from folks who just see the problem differently because they're not stuck in the same thinking patterns as you. But I continue to worry that we don't have a mechanism always for supporting those views. And this is speaking institutionally as a representative of, say, I work for NASA and I sit on some NASA committees. It's how do you encourage folks to pursue their ideas and be successful when sometimes the high risk, high reward science doesn't pay off for a very long time. And I don't have a solution to that, which means it's an interesting thing to think about, because if I had a solution, it wouldn't be very interesting to keep thinking about it. But as I continue to age in my career, it's something that I continue to bring into policies, say at, space, at my institute, wherever I'm working, is to think about, how do we break the barrier of being afraid of failure and what the consequences might be, so that people actually do that really interesting thing. And I think now we're at a point where we're getting people into the room, maybe not perfectly, and thanks to a lot of efforts like your own, we are getting people into the room. And I'm thinking more about, like, how do we support them and support their views and keep them going? And it's a really hard thing when the resources are so constricted like they are now.
Well, at MIT, it's part of the culture. So as a professor, luckily, you're paid a salary. So it's up to you if you wanted to take a small amount of time and a small amount of your students' time and try to invest in something risky. And I always do try to encourage people the workarounds we've been talking about. You have the pie chart of all the things you have to do. Like, let's imagine you're home and it's dinner, after dinner, you have all those chores. Are you going to carve out a tiny slice for me time? Yes, you are. And that's like in research, I try to encourage people with the pie chart. There's a tiny slice of time for you to take a risk and take time, and you might not have money for it, not right now anyway. So part of it is fear, resources, but a part is just culture.
Thanks, Rachel and Sara. That was a great discussion. I think this really highlights as well, like, how important like public outreach is, and being able to communicate this science, so that a broader audience can understand why it's so important. So a related question now for Kristen. So your work uses magnetic fields to understand star formation, and you focused on bringing your research to public learning. So considering Vera Rubin, how Vera Rubin opened up spaces for women scientists, how have your outreach efforts, such as star parties and teaching, helped girls see themselves in the sky and enter astronomy with confidence?
Yeah, thank you. So as Taylor mentioned, my research focuses mostly on magnetic fields and trying to detect very weak magnetic fields. We try to detect magnetic fields in our own galaxy that are a few billion times weaker than the field at the surface of Earth. And that's a pretty difficult thing to do. And, we talk about failure a lot. In my field, it's actually very rare to be able to detect something. So we publish more non-detection papers than we do detection papers. So even if you don't find what you were hoping to find, the time spent researching that is still very useful to do. As far as star formation goes, we think that these magnetic fields could be keeping the stars from forming. They could be supporting the material that would typically collapse to form stars. So it's a very interesting question because you think, well, stars, if you ask someone to think about astronomy, they'll probably say stars, right? So as fundamental as stars sound, it's something that we still don't have an answer to. So, I mean, it's a really important question to investigate and just, communicating that the best results aren't always ones that prove something, right? It could be those non-detections as well. I think we can apply that to our own lives in many ways, right? We can take our failures and we can learn a lot from them. I'm not saying that not detecting a field is a failure, right? But there are many things that don't turn out the way we expect them to. But you know what we keep doing? We keep trying, right? And we find a way, we find a path, we find some way that we can get there. So I think that's something, that we can take from science and apply to all, different avenues of our own lives. In terms of the outreach, I do enjoy doing a lot of community engagement work. At Davidson College, we have a few community engagement events per year, and I do a lot of that. But my students also do a lot of that as well. Because I feel that it's important for them, no matter what they're going to do in life eventually, right, to learn how to communicate science. Even if you're not going to be a scientist, the students who enroll in my just intro general astronomy course, they're going to be teachers, they're going to be parents, they're going to be those people on Capitol Hill that are advocating for, science budgets, or in a community hall somewhere proposing, I don't know, lighting for their communities that hopefully will not contribute to light pollution, right? So I think it's important for everyone to learn these skills. So I definitely, value involving everybody in that, not just scientists, right? So it's not just my research students, it's not just the faculty at the college. Most of the effort towards our community engagement program comes from students who don't consider themselves scientists, who tend to be actually very science phobic, very math phobic. But yet they learn that they are able to make a meaningful contribution to the public. And I think that is a lot in the spirit of Vera Rubin, is just including everybody. And one of the things that I'm really interested in and I'm trying to focus a lot on is not just community outreach for the general population, but for people who might be a little different from the general population. So for those who might be blind, or for those who might be not be able to hear, or who might be mobility impaired, right? How can they experience astronomy? And that's one of the other things I push my students to think about. So in all of our exhibits and all of the things we create, I ask them to explicitly think about how we can include everybody. So no matter what the age, no matter what the ability, no matter where these people are coming from that come to our events, everyone is able to learn something, walk away with, some experience, some memory, some knowledge, some inspiration that they didn't have before they came. So I think, again, that's very much in the spirit of Vera Rubin. And I think that's important for everyone to remember, is that you don't have to be a scientist to teach people about science, or to inspire people, in science. We can all do it, right? And that's going to be really important for our future, to attracting young women, everybody, not just women, but everybody to science.
That's such a powerful reminder that space belongs to all of us. This world belongs to all of us. Understanding it, being curious about it, just appreciating it because it's beautiful. That's something for all of us. And I love the way that you've spoken about that, and bringing this new level of understanding to everyone, so that we can all, appreciate and love it together. So I'll say to our audience that we are nearing the end. We're approaching a Q&A session. So I've seen a couple comments in the chat and in the Q&A. So if you have questions for our incredible panelists, start thinking about those. Consider putting them in the Q&A that's coming up. But before we get to those questions, thank you so much, everyone, for all of the very thoughtful and vulnerable and expansive answers that you've given so far. The last question that we have is open to everyone, and we are wondering, what's one piece of advice that you would give to a young person who wants to have a career like yours or be like you? What would you tell them? I'll give you a moment to think, and whoever's ready can hop in.
Go ahead and jump in. I think that many times, especially as, young women, we're afraid to appear weak, right? We want to appear strong, and we want to do things that make us appear strong. And I think many people think that asking questions is a sign of a weakness, right? That you're asking a question because you don't know something, and maybe you should know that. Or it's good to ask questions. And if it weren't for asking questions, I would not be where I am today. And I'm not just talking about an academic sense. Like, of course, okay, you're sitting in a classroom and the professor says something, the teacher says something you don't understand, you raise your hand and you ask a question. Yes, of course. I'm personally very introverted. Like, I'm not normally the type of person who would just walk up to somebody and say, "Hey, this is me, this is my name, and would you like to talk to me?" Like, that's not what my personality is. Um, but if it wasn't for asking a question, I probably wouldn't be studying the things that I'm studying now. I probably wouldn't have been in the grad school that I was in. You know, thinking long term, I wouldn't have met my husband. I wouldn't have had my kids. I wouldn't have the life that I do now. You know, and that was, you know, I was somewhere and I saw somebody, I knew who they were, and I respected their research work, and I said, I'd like to work with them. And I got the courage to just go up and ask a question like, "Hi, this is my name, and I'd love to work with you. Can you talk with me?" And that led to the position that I had in graduate school. You know, and it was all about having that courage to talk to somebody, to ask a question. And it took me a long time to realize that asking questions, it's more of a sign of a strength, right? Because you have the courage, you know yourself, and you know, kind of that Vera Rubin, right? You're confident enough in yourself, right, to ask the question, than it is a weakness. So that would be my piece of advice.
So I'll go next. Kristen, I think you knocked it out of the park with your answer. I want to pull on well, two particular threads. Because I wrote down, be curious. You know, that would be, you know, the advice I would give is always be curious. And in particular, at least from my experience, be curious about the bigger picture. You know, you know the work that you do, but be curious as to why that work is important or where that work might go or who else might be interested in that work. So be curious about the bigger and bigger picture because you never know where that bigger picture perspective is going to lead. And then the second thing I would say is, you know, as a woman in a male-dominated field, accept the fact that you're going to stand out. You know, don't try to look like everybody else in the room. Embrace the fact that you're going to stand out and own it. And I know that that's easier said than done sometimes, but it's part of our reality, and we can be proud and comfortable and confident in ourselves. So own the fact that you'll stand out a bit.
Yana.
I, I suppose my answer is just perfect follow-up to both of the previous answers in the sense of, you know, I always have to say, you know, unapologetic representation, but um, when you enter these spaces and you are someone who stands out because no one else looks like you, I would just encourage you to remember that you have every right to take up space, whether it's physical space, whether it's vocal space in the sense of asking questions, or sharing your insights, your thoughts, because we all have something unique to contribute. Um, you know, especially as women in male-dominated fields, or if you're another minority and insert X majority, you know, a lot of times there's a lot of entitlement, you know, white men often feel very entitled in these spaces. And so you should get to share in that entitlement too. You deserve to be here and to take up just as much space as everyone else in the room, and to never forget that.
I'll just follow on to that and say, I loved what Kiana said. And part of it is building confidence so you can fill that space and hold your head high when you enter the space. And so finding a way to build confidence, whether it's through your peers or read a book, join a class, because all those microaggressions chip away. So you want to have like a conservation law for confidence. And that's my advice.
On that note, I'll add that personally, I found that finding a community was so important. I think several people here have talked today about building a community and finding that support network. Um, you know, at points for me, that came from other women of color who were not in physics, but were in the engineering department, or, you know, finding your people. When I was in grad school, I was so lucky to find friends like Taylor, we were all able to really support each other. So, and Kiana, you mentioned that you had to go kind of far and wide to find those people who really supported you. But I think something that can be so encouraging and also give you a space to not have to be strong all the time and to have a little bit of doubt or just need a break from being perfectly confident and everything like that. It can be really important to find people who support you and really care about your success. Uh, well, I'll ask if there's any final thoughts from our panelists about this question or any other questions that we asked today. I think Sakira is getting ready to come back in. Um, but if there's any final thoughts, we'd love to hear them. Else, Sakira, I think the floor is yours.
Awesome. Thank you so much, Madeline. And thank you so much again to everyone for this amazing and inspiring conversation. As mentioned, we are now opening up for our general Q&A for both our panelists and moderators. So if you do have a question, please send it our way via the Q&A feature at the bottom of your screen. And I know that we already had some folks jumping in. And so I will go ahead and dive into our first question, which feel free, anyone can jump in at any moment. But our first question from our audience is, as someone who previously studied astronomy, astrobio in particular, but is now out of practice, is there any advice on how I get back into it? Specifically back into academia, where there's hurdles for reference letters and research experience that I don't have, and I'm not sure how to transverse.
I've seen people successfully try to do this. It does involve networking, and it helps really if you live near some kind of university community where you can go to talks, show up, meet people, mingle, and try to get some kind of volunteer job if you have time or even like a paid position. But it's really mostly about networking. And I hope you can find someone to help you, even people networking to get a job in an area that's not related to astronomy.
I can
Thank
jump in here as well. I could echo that because, if you think back to what my piece of advice was, it's not be afraid to ask questions and to approach people. And I think this is exactly what you need to do, right? Whether you live close to a university or whatnot, but even if you send an email, there are many faculty members, we get emails all the time that might, just hey, do you have any outreach events coming up? Do you have any talks? Do you have anything like this? I know also in North Carolina, this wouldn't be true of everywhere, of course, but we have a lot of amateur astronomers in North Carolina. And in fact, they hold their own meetings, right? There's the North Carolina Astronomer meeting, and it's full of all sorts of professional astronomers go, but also amateur astronomers. And that's a great place where you can go without necessarily, the faculty credentials or a membership that could be, very costly to attend, like the American Astronomical Society or something. And you can go and mingle and meet people and forge some connections there. So I encourage you just to look at what's local to you and take those opportunities.
Rachel.
Yeah, I'm going to make two recommendations. The first recommendation is to go to the zooniverse.org. That is a site that does a great deal of citizen science where you participate in scientific projects with researchers, and there's message boards and communication. And that's a great way to get back into what some of the really interesting questions are now. And it is free and very accessible. And it can start conversations, especially if you're in a rural area where you can't just go to a local university and maybe get the support that you need. That can start forging some connections, at least, even if it's just with other people who have similar interests as you. The other thing I want to recommend, and full disclosure, I am a board member on for the Astronomical Society of the Pacific. And ASP's mission is to connect amateurs, professionals, and educators. And so their platform, Learn at ASP, although it's geared a lot towards teachers and giving teachers the foundations they need to teach astronomy and physics concepts in the classroom, also has a number of really great lectures and other programming that can get you back into the spirit of astronomy and what people are doing. Because there's really, there's a popular science language that I think we use a little bit here when we're talking about our science, but there's also the technical jargon. And so I think it's really important to start being conversant in that jargon and listening to how people use it to help you also be conversant in making connections. Because I'm very open to letters from students and things like that, but often, they're hard to answer because they are not maybe using the language correctly, which is not to say don't do that. It's to say, you know, it can be useful to engage in a way that is slightly easier for the other person to engage, because sometimes it could be, a treatise, a journal article to kind of answer the question that's being asked. But those two venues, the Astronomical Society of the Pacific, so I think it's astrosociety.org, and then also the Zooniverse platform or other citizen science platforms are great ways to start becoming more conversant and get at least make yourself feel like you're up to speed. You're probably pretty close. And then once you have those connections, it can be much easier to make the next connection and make the next connection.
Thank you all so much for your responses. Was there anyone else before I move to what looks like will be our last question for this afternoon? Alrighty. So we offer a women's history talk on women in STEM for corporations and organizations. And at the end, there's always the question of how can I introduce my daughter, niece, etc. to STEM? What can someone outside of the sciences do to encourage the next generation?
I'll jump in on this one. A huge thing that my parents did for me, my dad is an engineer, but my mom is not a scientist, and they were both very good at this, is they always helped me find the answers to my questions. They never said, I don't know, stop asking me. They always said, oh, that's really interesting. Let's see if we can figure it out together. And that was so important for me as um, a budding scientist. And I now, as an educator and curriculum developer, something that is a huge goal for me is how do I create resources where kids and their grown-ups can learn together? Because there's so much power in figuring stuff out. And so I think one of the best ways that we can support young people in their any interest that they have, um, is engaging with them together and saying, yeah, let's figure this out. That is an interesting question. I'm sure there is a way that we can approach this. So if you have a young person in your life who is expressing interest in science, that's a way to do it. If you want to maybe encourage or stoke more of that interest, similar things, saying, "Oh, I wonder how this works. Or would you like to figure this out together?" And bringing them to events like this, events at the library. Public libraries always do a great job of expanding exposure to different kinds of knowledge and things like that. So from my life, that was something that I really appreciated. My parents did.
I think also sitting down and watching, there's some really great science programming. You do have to be careful and you have to know that you're watching something that is a respected, I don't want to say respected, but a trustworthy source, right? It's very easy to watch some AI chaos instead of watching, a real person. But there's things like PBS Nova that does wonderful short documentaries. YouTube has a lot of really good voices as well. And just do it with them. I think, like Madeline was saying, you can help them find their answers, but you can also just be curious with them and sit down with them and engage. And maybe they're not interested in astronomy, maybe they're interested in chemistry, maybe they're interested in something else. But with my nieces and nephews, there's a gaggle of them and they're about to invade my space. But I just am interested in what they're interested in and try to show that I care and I value their point of view and their perspective and what they're interested in. They don't know Aunt Rachel is a scientist, right? And that she's on a big panel. They don't always know that. They just know that Aunt Rachel cares, that wants to hear them talk about um, gosh, it was Roblox yesterday, I think. But but then you can also lead that conversation into other things. You can I feel like being a scientist, asking questions is very innate. We're all born with that. And at some point society can train us out of it. But the practice of science is a little different. It's actually knowing how to find answers. And you can help them in the practice of science by helping them, like I was saying, find resources that are trustworthy. Um, and you can help them with their thinking. You can show them how to ask a question of, Google or Wikipedia or something like that. I would recommend staying away from the Chat GPT. It's not always right, and it can be very confusing and it's very hard to tell. But you can show them how to get started in the practice of science. And being a scientist at the end of the day as a profession is is ultimately about a lot of training to get to the current forefront of how to do science. But if you feel confident about asking questions and confident in your ability to find answers to them and then to go to the next steps, that will serve you well through the training if you want to be a scientist long term. But there's lots of ways to contribute to science, writers, just being community members who are interested, volunteering, taking your telescope out on the street on occasion, or the cul-de-sac, and maybe having kids come around. So there's lots of ways to be a participant in science, but just making people feel like their questions are important and worth hearing is really important.
Thank you, Barb.
Yeah, I would say yes and to the fantastic answers so far. And for my not whole is find ways to encourage just a well-rounded and as diverse set of opportunities or insights or experiences. So it could be the local natural history museum, or it could in fact be, sitting in an empty parking lot watching airplanes take off, across the street at that airport. Those kinds of things, just the find those opportunities that might be a little bit tangential initially, but they're going to open the aperture and they're going to spark, you never know what kind of curiosity you're going to spark when you just start, providing, more insights, just a wide variety of insights.
Thank you all so much. Did anyone else want to jump in, or have any last words for our audience? All righty. Well, I just wanted to thank you all so much again for your time, and for this amazing conversation. And as we close today's celebration, we want to extend a heartfelt thanks to our incredible panelists and moderators. Your collective wisdom is a powerful reminder of Vera Rubin's legacy, one rooted in curiosity, mentorship, and the belief that science is for everyone. And to our audience, thank you for joining us as we honor and celebrate Vera Rubin. As we leave this space, let us carry Vera's words with us. Each one of you can change the world, for you are made of star stuff and you are connected to the universe. Thank you all so, so much again from the National Women's History Museum.
Thank you, everyone.
Thank you.